part?
Sorry, you're not recording.
Yeah,
Question, sir.
go ahead.
Um, when this term is finished, are we going to switch science subjects?
Yeah, so next year you will be
Bio.
doing, I believe it's bio or chemistry. I'm not sure.
Sir, you can't keep me in a physics.
I am not able to do that. All right, let's begin. Let's begin. So today, as I said, we're going to do magnets. Now, before, right? How could I forget that? Let me bring this up. All right, so let me know if you're seeing this.
Sir, you're talking very low.
All right, let me try and fix that. So let me know if you're seeing this. Are you seeing this?
Yes, sir.
Yes, sir, you're talking very low,
What
sir.
is that?
All right, so
Sir, what is
these,
the word at the top of the screen? Not magnetic force.
the Java Lab, this one.
Okay, sir. Yes, sir.
All right, this is a program that we're using to do this experiment. All right, so if you have it, this is what is this here? Who wants to guess what this is? Who wants to get what this particular thing is right here? All right, so this is a magnet, right? Yes, no? This is a magnet. Or this is a structure
Sir,
of a magnet.
speak up in your mic.
All right, so this is your magnet, right? Now we have a north section here and we have a south section here. Now this is showing that the magnets are, what I think is happening here. The magnets are attracting each other or are they repelling each other?
They are attracting, sir.
Exactly. So whenever we
But there's
come,
sir, the intersection, in the intersection, it is the magnetic force pulling them together.
Exactly. So in here, we have the magnetic force pulling the south pole, right, and the north pole together. Now, tell me, just at this person, tell me what is happening now. Are they attracting or repelling each other?
They are repelling, sir, because you don't see corresponding lines.
Exactly. So the lines
Who said
here,
said that?
Miss Kitchener, you were saying something?
Never mind, sir.
All right. All right, so you have the lines, you see them sort of branching off. So in comparison to these lines connect, right? These lines come together and they connect,
Yes,
right?
sir.
So the north essentially connects with the south, and we see that coming here. In this one now, we see that the south lines are branching off and they're essentially not connecting, right? They're not connecting. So that shows that these lines are repelling each other.
Opposite.
Exactly. All right, so we can now go to our presentation here, right? And a magnet essentially has two poles or two ends. And we saw that earlier. We have a north pole,
And the south pole.
right? So we have a north pole here, and then we have something, say the south pole here. This would be our south pole. All right. Now a magnet will attempt to line itself up with the magnetic field of the Earth, and we'll see that in a few slides down. But that is what we want to accomplish on this slide. That magnets have two types of poles. We have a north pole and we have a south pole. Now we have some technical applications of magnets, right? We use large magnets, right, powered by electricity to pick up heavy loads. You know, when you have the tanker, for example, you have a truck here, not the best truck in the world, right? And you would have something like a clamp, something like
Yes,
this.
sir, like a crane.
Exactly, like a crane. So a crane is a form of electromagnet that is used to take up larger materials, right? So magnets are used in meters, motors, and even loudspeakers. You know, like if you have a toy and you see the speaker, they have some small magnets inside of it that you can play with after your toy, I don't know, get destroyed or so forth. Magnetic tapes are also used in audio and video recording and some computer disks. All right, so magnets are basically right in most of your things with circuits, most of your items with that has to do with computing or so forth. Magnets are involved in these. All right, and we have some more uses here, which we won't focus on. Right, the aim is not to get you the uses of magnets. Right, these are just some examples. All right, so these can go. Yeah, these are very complicated uses. I'll update your notes, right? And I get these out of your way. But these are just some applications to help you to understand magnets a lot better. Now, as we just saw, magnetic forces exist between magnets. So you will have like poles repelling, right? So we saw a while ago the South Pole here.
And the North Pole there.
All right, let's put a South Pole here. We're just using the repelling one. And we saw the lines looking something like
Yes,
this.
sir, being scattered.
Exactly. So they're not connected, right? We see that there's some form of repulsion here, right? So the lines are not connected. On the other hand, opposite poles attract. So if we have a North Pole here and we
And
have a
the
South
South Pole
Pole,
there.
right? You
It
see that they connect.
attracts.
Exactly. They essentially attract to each other.
Yes, sir.
Right? So that is what we really want to get for this slide. Right, as I said, today will be a very easy class for you, not what you're really used to.
And very short.
Right? Now, as we said earlier, right, you'd find that the magnetic fields, the magnet will always try and line up with the magnetic field of the Earth. Now, if you have a magnet here and you have a south pole, right, the south pole of the magnet will want to attract to the north pole of the Earth, right? And the north pole of
Yes,
the
sir.
Earth will attract to the south pole of the north pole of the magnet will attract to the south pole of the
Attract to the
magnet.
South Pole of the Earth.
Exactly. So these they essentially come together, right, and they line up with each other, right. So you'll always find that the magnet will try its best to line up with. That's why you can use that's how you can use compasses, right? Compasses have magnets inside of them that essentially line up with the Earth, and that's how you can know the exact position you are away from the north. All right. So you can find the pole of a magnet, right? One easy way to tell which pole is in north and which is the south is to set your magnet near a compass, right? So the needle on the compass that normally points towards the north pole, right? So the needle of the compass that normally points towards the north pole, um, towards the north pole of the Earth will move the magnet south pole, right? Let's me repeat it again. So one easy way to find out which is the north and which is the south, is to
Which
put,
is the south on a magnet, is
yeah,
to put it at a compass, and the point will move from the north pole to the south pole of the magnet.
exactly. So the north pole of the magnet would connect to the north pole as indicated on your compass, and I will show that. I'll give an example of that. Let me bring that up now. Where are we? Okay, it's loading. It's taking some time. I'll show two of them.
Sir,
Go ahead.
sir,
Hmm?
why you don't allow us to record?
Yeah, you can go ahead and record as well.
No, sir, you have to allow us
Oh,
from your laptop.
well, let me see. Um, I am not sure how to do that. No, but I'll try and figure it out hopefully next class. But essentially the recordings will be uploaded.
Okay.
So yeah, you were saying that the North Pole, right? The red here, you see this red arrow? This is
Yes, sir.
signifying the north. Exactly. This is signifying the north of, or the compass. This signifies the north of the compass. North. Now, if we, this is N on the compass, north on the compass. Now, if we move this magnet, right, we see that the north is also moving. So this compass is also moving. So so we know that this is, of course, the South Pole. If you wanted to find out which one is this, you could easily do that by just connecting it to a magnet, and then you would find out that this is the particular South Pole.
Yes, sir.
All right. So the North Pole of the Earth will connect to the South Pole of the magnet, right? And that would be the same thing around for the other side. So if you connect the North Pole to the compass, right, which will be the white part here. If you connect the North Pole to the South Pole of the compass, you would see that they are attracted to each other. All right. So everyone is clear so far?
Yes, sir.
All right.
Yes, sir.
Anyone not clear?
Sir, see everybody gone.
All right. Anyone not clear in here so far? Are we okay with magnets and how they interact with the compass?
Yes, sir.
All right. If we move this North Pole, we realize that the North Pole is now connected to the South Pole of the magnet. Right. So the South Pole is this one here, the white one. South Pole is a magnet. So the North Pole of the magnet is connected to the South Pole of the compass. All right. I was looking for one more simulation. I'm not seeing it. Let me see to show you. Yeah, I'm not seeing it, but we'll work with that. Yeah, we'll work with that for now. All right. So the last two slides, right? We have two more slides up, or three, right? Very easy slides. So permanent magnets, right? So unmagnetized iron, which would be regular iron, can be magnetized by placing it near a strong magnet, right? Or essentially hitting it with a magnet. So this process can be also reversible if you heat it, right? Or you hammer it. But essentially, if you place if you place a coin beside a magnet and then you place a coin on that coin, what will happen? Have you ever done that experiment before?
What, sir?
What if you place a coin on a magnet and then you place a coin on that particular coin? Will they attract or will they repel? Or
Sir,
nothing will
they will
happen?
attract.
Exactly.
They will
So,
attract.
so that particular coin will be, that particular coin, we call that coin magnetized. So that means that it is now giving off a magnetic force. All right, that's what we call that particular magnet. It's no, or that iron. That iron has become magnetized. All right. So magnetic poles always occur in pairs. So you never find a magnet with just a north pole. You will never find a magnet with just a north pole, right? Your magnet will have a north pole and a south pole, right? If you break up
Sir,
magnet
what
in
if
half,
you break the magnet in two?
if you break the magnet in half, it will still establish a north pole and a south pole. Trust me.
Sir, question.
Hmm?
If you break the magnet in two, can the magnet mend itself? Out
That's
of
a very
curiosity.
That's a very good question. It will not mend itself like you say, it will not mend itself back to original. It will be two magnets now. So if you have a magnet here, that's a very good question, right? If you have a magnet here and it has a north pole and a south pole, and you break it in half, you will have two magnets now. This will have a north pole, this will have a south pole, this will have a north pole, and this will have a south pole. And these two points, what will happen here? What will happen here? They will attract or repel.
Repeat,
Sir, they will attract.
Yeah.
Exactly. So they will attract. All right. So if you have a big magnet and you break it in two, and it will still have north poles and south poles. You will never find a magnet
with two north poles or two south poles.
will never exactly. So you'll never find a magnet with two north poles. This will never happen. Let me use
So, Miss
that.
Smart.
All right.
Same as sir not teaching again.
So you'll never find this. Yes, Mr. Golden. Yes, Mr.
Sir,
Golden.
as
That's
you
good.
know, so you're not teaching vain.
Yes, Mr. Golden. All right. So you'll never find a magnet with two south poles and two north poles. Right? A magnet will have a north pole and a south pole. If you break the magnet, it will still have a north pole, south pole, north pole, south pole. And if you break it one more time, right? North pole, south pole.
It will still contain the two poles.
Exactly.
Yes. Exactly.
All right, so I believe this is our last slide. Everyone clear on this so far?
Yes, sir.
Yes, sir.
Yes, sir.
All right.
Sir,
Go ahead.
why did they cancel exam?
All right. It is mostly for the grade 11s and also for the fact that, all right, you have, let me see, give me a second, let me answer the question the right way. No, there are 34 participants in our group, in our physics group. So that would include me, right? So therefore, there are approximately 33 students in class, in our physics class right now. And how many students are on the Zoom call now?
7.
All right, so 7 including me, so that would be 6, right? No, 6
Yes,
students
sir.
are on the call, and 34 students are are in class. So how many students are not in class? How do you calculate that? If we have 34 students in all total, and we have 6 students in class now, how do we calculate the students not in class?
Sir, there would be 28 students not in class. But,
Exactly.
sir,
Students not in class. Yeah?
but the drama teacher said that the only reason they canceled it was because some children didn't have Wi-Fi. So I am saying, why don't they let them come to the school and do their exams so that it can benefit all of us instead of the good stuff of everybody?
All right, so there are many different reasons why. First of all, there are most of the times you have maximum you'll have 14 students in class, right? So the fact that students are not able to do the exam, that's a good point, and the Wi-Fi issues. But also on a regular day, you won't have students in class participating in class, so therefore we're not able to teach them. They won't understand the topics. Right, so that's why we really push back the exams until next year.
Again, the good stuff of everybody.
All right, so we have one more slide and then we're finished. So
Yes,
north seeking versus south seeking, right? So what this means that bar magnets will seek or point to the geographic north or south pole. So the geographic north, as we said, we have the earth here. We have said this about 4 times in class already. You have the north pole up here and the south pole. A magnet will align itself so that the south pole is up here and the north pole is essentially down here. All right, so the geographic north is equal to the magnetic south, and the geographic south is equal to the magnetic north. So bar magnets will always seek to point in the geographic north or south pole. They will always try and align themselves with the magnetic field of the earth. That's why you can use compasses, right? So I don't want to go too in depth with this, but we can use magnets to determine where the north is just by pointing the south pole or getting a south pole pointing in the north direction. That is it. So wherever the south pole is directed without any force attached to it, that is our north pole. So wherever the south pole of the magnet is, that's where the north pole of the earth is. All right, is that clear?
yes, sir.
All right.
That is class.
Anyone doesn't understand or having trouble or don't understand anything so far that we have done? Please indicate no.
And that is class.
All right, so I take that as everyone is okay. And if we get some questions on this in exam, we should be good, right?
Yes, sir.
Yes, sir.
Yes, sir.
I hope so. I hope so. All right, so that's it. Well, I
Bye,
saw a
sir.
message. I saw a message here. Give me a second. Let's check to see if it's happening in the chat.
Bye, sir.
All right, so that is it for today. All the best, everyone.
All the best, sir.
All right.